Question 13 about inverse functions. So we want to show in A, B, C, D, F, and G the inverse to each other. So how to prove that? So F composed with G if equals to X, and G composed with F also equals to X. So if these two equations, if we have those two equations, then we see F and G are inverse functions. Okay, let's apply that. So F composed with G, in this case, is F takes G as input, or G is X divided by 2. And F multiply 2 to the input. Yes, 2 times half X, that's X. Now G composed with F. G takes F as input, well, F is 2X. G says divide the input by 2. Indeed. So both equals to X. The composition function equals to X. So by this theorem, excuse me, F and G are inverse with each other. Okay, so it's verified. So to verify, we compose F composed with G, we do G composed with F. So let's do the same for B. F composed with G. F takes G as input. G is cubic root of X minus 4. And F add 4 to the input, so cubic root of X minus 4 is the input, add 4 to it, then raise by 3. Well, negative 4 plus 4, that's 0. Cubic root of X raised by 3, indeed, that's X. Well, G composed with F. G takes F as input, or F is X plus 4 raised by 3. And G says cubic root of the input, then minus 4. So cubic root of the input, X plus 4 raised by 3, then minus 4. Well, X plus 4 raised by 3, then cubic root. The index and the exponent are the same. 3 over 3 is 1. So we get X plus 4. Then minus 4. Yes, also we get X. So B is verified. F and G are inverse. Now let's see C. F composed with G. F take G is the square root of X minus 7. Then F squares the input, then plus 7. So squares the input, then plus 7. Square root cancel each other. So we have X minus 7 plus 7, it's X. So G composed with F. G takes F as input, or F is X squared plus 7. And G subtracts 7 from the input, subtracts, so this is the input, X squared plus 7, subtract 7 from the input, then square root. 7 minus 7 is 0, square root, so X squared square root, that's X. So C is verified. Now let's see D. F composed with G. F takes G as input, 5X minus 11 divided by 3 minus X. Well, F says, F has a numerator and denominator. Numerator multiply 3 with the input. So 5X minus 1 divided by 3 minus X is the input, then plus 11. Denominator is the input. Input 3 minus X plus 5. Now, so this 3 multiplied by this rational expression is the same as 3 multiplied with the numerator, right? Then 11, we want to multiply 3 minus x divides itself. Well, that's 11 multiplied by the numerator. So the numerator becomes 3 times 5x, 15x. 3 times -1, -3. 11 times 3, 33. 11 times -x, -11x. Then the common denominator is 3 minus x. Well, then the numerator now 15x minus 11x, 4x. Then minus 3 plus 33, that's plus 30. Divided by 3 minus x. Right, so that's the numerator. Now denominator. So we need a common denominator of 3 minus x. So we multiply 3 minus x divided by 3 minus x with 5. Now this 5 is multiplied by the numerator. Right. So I have 5x minus 1 plus 5 times 3, 15. 5 times -x, -5x. Then all divided by 3 minus x. 5x minus 5x becomes 0. So 15 minus 1, 14. So denominator of 14 divided by 3 minus x. Now, the numerator, we have a denominator 3x. Denominator will have denominator 3 minus x. So we could just ignore that. So that becomes 4x plus 30 divided by 14. So this is definitely not x, right? Oh, hold on a second. X plus 5. I think, did I miss something? No, I didn't, right? 5x minus 1. Oh, 5x minus 11. Yeah, you see, this is minus 11. I did something wrong. So this is a minus 11. Then this becomes 33. So this is gone. 15x minus 11x, that's 4x. We don't have this. We don't have this. Then the denominator. So this is 5x minus 11. Then we'll have 5x minus 11 plus 15 minus 5x. So 15 minus 11, that's 4. So that's 4, that's not 14. 4x divided by 4, indeed, that's x. Yeah, I made mistakes for calculation. I write this input wrong. The input is 5x minus 11, not minus 1. Now let's calculate. So that's f. So f composed with g is x. Let's do g composed with f. So g composed with f. G takes f as input. 3x plus 11 divided by x plus 5, right? That's f. Then what does g do? G have numerator and denominator. In the numerator, we have 5 times the input. 3x plus 11 divided by x plus 5. Then minus 11. Denominator of 3 minus the input. This is 3x plus 11 divided by x plus 5. Now let's have a calculator. So this 5 is multiplied with the numerator. Then 11, we need a common denominator of x plus 5. Same thing here. 3, we need x plus 5. We need to multiply by 1, basically. Then this 3 multiplied by the numerator. So 5 times 3x, 15x. 5 times 1, not 1, 11. 3x plus 11. 5 times 11 plus 55. Then minus 11 times x, 11x. negative 11 times 5 is negative 55. Positive 55 minus 55 adds up to be 0. So 15x minus 11x, that's 4x. Now let's see denominator. Denominator will have this 3 multiplied by the numerator. So we have 3x plus 15 minus 3x minus 11. 3x minus 3x becomes 0. 15 minus 11 becomes 4. And the denominator is the same thing, is x plus 5. Let me use a different color. You see the denominator? In the numerator, we have x plus 5. In the denominator, we have x plus 5 as the denominator. So they just cancel out. So let me give you a simple example. Let's say I have 1 divided by 2, then divided by 3 divided by 2. I claim this can be simplified. This can be thought as 1 divided by 3. I just cancel out 2 here because both being divided by 2. But mathematically, that's half divided by 3 over 2. With the half multiply, we change division into multiplication. Then we take the inverse of the second one, which is 2 over 3. Now 1 times 2 is 2. Right, 2 times 3 is 6. Simplified, that's 1/3. So if we have 2 layers of division, and the denominator the same, in this case, the denominator in the numerator is 2, denominator in the denominator is 2. So we just ignore them. Okay, that's 13.